Hello, this is Nicholas from Silicon Chip Publications, and today I'm just going to quickly go through our latest issue, the June 2026 issue of Silicon Chip Magazine, which goes on sale Monday, 25th of May, which should be around the time this video goes live. Here's the cover of the magazine. You can see we have a pinball machine, which is a new major project that you can build from scratch. It involves 3D printed parts and electronics to control it, so that's a pretty fun project. And then we have this comfort indicator. It's like a thermometer, except that in addition to showing you the temperature and humidity, it can also show the dew point, and it has some alarm features. It uses an e-paper display so that it can use a single cell, rechargeable cell that will last for months. We also have the second half of our article on analog computers. So let's have a look at the contents page. I'm not going to go through every single article in the magazine, but I'll go through all the major ones. So starting with the features, we have the second part of our article on analog computers. The first part was more of a historical old analog computers that were used for quite some time before electronic computers became practical, but now they're coming back because there are some advantages of analog computers for modern workloads. So that's what the second part is about. We have an article about PCB quality that was sent to us by PCBWay, who's a manufacturer. We had a look at it and thought it was quite interesting. There's some interesting points made in there about PCB quality. It does promote PCBWay, but it's just interesting on its own merit. So we decided to publish that. We have this article about a whole home sound system. So Julian Edgar installed speakers throughout the new house that he's building with multiple amplifiers and switching and so on. And he talks about all the decisions that he made and the problems he came across and that sort of thing. We also have this article on working with e-paper displays, and that ties into the comfort indicator. So this talks about what we had to do to get e-paper to work and some of the advantages and disadvantages that are not explained in the comfort indicator article itself, because that concentrates on the actual device and building it and using it. Then we have the pinball machine. So this is part one of 5 different parts because it's quite a complicated device. We'll get to that once we start looking at the article. Comfort indicator we've talked about, and this was prompted by the fact that somebody pointed out, obviously you can buy digital thermometers, but the ones that can show the dew point are very expensive, and this one is a relatively inexpensive device. And it's quite useful. It's a useful figure because it essentially tells you how comfortable the temperature feels relative to the humidity. Then we have a simple USB power monitor. We've published a few power monitors before, USB power monitors. This one supports USB 3, but it also is quite simple and cheap. We published one about a year ago that supports USB-C and USB 3. That previous one was a bit more involved. Not ridiculously so, but this one's definitely simpler. So it might appeal to some people who want to just put something together quickly. And then we have a radio article on single sideband transmitters. So there are 3 circuits with a board that you can use to build any of them. They fit into this 3D printed case, although they can also fit into a salvaged push-to-talk microphone case, which is quite clever, I think. Let's have a look at the first article now on analog computers. And it basically starts talking about how the fact that a lot of modern processing techniques, including for artificial intelligence and machine learning, involve matrix calculations. If you don't need exact precision, then matrix calculations can actually be done very quickly with analog computers. So that's part of the reason why they're coming back. They're becoming more common again. We talk about, and one of the big advantages is energy efficiency, because a digital computer has to step through all the different elements of the matrix to do the calculation, whereas an analog computer can use physical laws to do it all at once. This shows here an example of how that can be done. And we talk about some of the challenges and advantages and companies that are using these techniques. There are also optical techniques that also count as analog computing. Some of the devices that are available to do it, including some that IBM and Microsoft are developing. And we also talk about these field programmable analog arrays, which are kind of like a analog equivalent of a field programmable gate array. And you can see that you can actually just buy devices off the shelf that do this to experiment with. So that's the analog computer article. And now we move on to the first part of the pinball machine. You can see from the photo, the black and yellow and blue parts are the 3D printed parts, and they're printed in sections and joined together. Painted marine ply board forms the deck. And then there are solenoids here that actuate flippers and bumpers and kickers. And this is fully customizable too. Obviously, we give it enough information to recreate our design, or Phil's design, but Anybody who's building this pinball machine can do it however they want. They can have more bumpers, fewer bumpers, no bumpers. They can move them. They don't need. You can have this ramp, or you don't have to have the ramp. You could probably you would copy the flipper and lower deck area, but you don't have to. That could be changed if you want to. All the files are available to modify if necessary or to print. I should point out that this is the sort of project where you really need a 3D printer. It, while some other projects there are 3D printed parts and you can just buy them or get somebody else to make them, it has so many 3D printed parts that you'd really want to buy a printer if you're going to do it. And obviously, there's also a lot of electronics involved. So we get in here, we show here's the control board in the center, and we have the bumpers, kickers, flippers, loader, releaser, bell driven by it. We also have some inputs, the target inputs, rollover inputs, buttons, and it also drives the score display and lights and things like that. So that board does pretty much everything. Here we go. Just have a brief overview of some of the 3D printed pieces that are used to build it. So the flippers and kickers and bumpers. As I said, you can customize that. You can use more than we did. You can use fewer than we did. You can move them around. It's a completely customizable design. This shows how ribbon cables and twin leads are used to keep the wiring neat. Wiring is always a bit of a nightmare on something like this. Here we show the different electronic modules. That's the control board, which is pretty simple, really. It's just a Raspberry Pi Pico 2 with a whole bunch of inputs and outputs connected to it. That's the power supply, which takes 24 volts from a DC supply and produces 5 and 3.3 volts for the rest of the circuitry. The displays, some LED boards that are used for the cascade and bumpers, and then a number of different breakout boards that basically let you connect a number of different things like rollover inductive sensors, LEDs, micro switches to a single ribbon cable that then goes back to the control board, and that keeps the wiring neat. This is our backboard, which has the speakers and display. Of course, that can be customized as well. And here we show the wiring under our deck and the control wiring, which is surprisingly neat for all the connections that are running everywhere. And you need to label it so that you can remember what you've done. We also talked about how the software works. The software is customizable, so it can just be used as is, but you might want to change the rules of the game. You might want to add different things, add more bumpers, add more rollovers, so that can all be changed. And there's the parts list for the electronic modules. And we have some kits for this. We have a kit for the control board, one for the power supply, and one for just the general parts that you need. And we can also supply the PCB. So that's the first part. The second part, we'll talk about making the deck and starting to assemble some of the mechanical parts. Sorry, the second part is about building the electronics. The third part is about building the deck and starting to assemble some of the stuff onto it. The fourth part is mostly about the 3D printing and the solenoids and getting that all put together. And then the fifth part, the last part, is about finishing the machine off and getting it working. So that's how it breaks down. It's all relatively straightforward. I mean, anybody with a reasonable sort of electronic and mechanical knowledge could build this if they want to. It's a major project and it would take some time, but we provide all the information that you need. You could just follow our instructions directly and you would get basically this pinball machine. And then if you wanted to change it, you could. It would be pretty straightforward to change it. So while it's a major project, there's nothing terribly difficult about it. So I think that's quite a good series for the magazine. And then we have this article on the PCB inspection report. So it talks about things like what happens at elevated temperatures. You know, how hot can the board get before it will fail? How resistant is it to chemical attack, corrosion, things like that. And it talks about what sort of properties you can expect. So here, for example, here it talks about if a PCB absorbs water, how much will it actually expand? So ideally less than 1%, well under 1%. It also talks about at what temperature will the board start to delaminate, things like that. So quite useful information to know if you're going to be designing PCBs for harsh environments like automotive or industrial applications. Then we have the comfort indicator. Here's the circuit. It uses not surprisingly, a microcontroller, a thermometer and barometer module that provides the temperature and humidity data. The e-paper display connects to this header, so there's some support circuitry for the e-paper, and then there's a power supply and battery charger. That's pretty much it. The e-paper is a monochrome. You can have white on black or black on white, as you can see from the photos. There's an example of both. and we've chosen different color 3D printed cases to match the display. But of course, you can print it in any color you want. And this goes into some details about how we've kept the power consumption low. Oh, and by the way, the case can also be, there's a version of the case for sitting on its side if you want to do it that way. The display can also rotate. There you see the single rechargeable cell, and there's a USB socket for recharging, and you can also, there's two positions for the socket to suit the two different case orientations. There's no data connection, it's a power only socket. But there is a header that you can connect for an alarm, an external alarm. There is actually an analog voltage output. So if you wanted to have a data logger to log the dew point, you could do that using that optional header. Here's the list of the parts that are needed. We have a kit for this. The kit is basically complete. The case is not included, but we are selling the case as well if you don't want to print it yourself. So you can get everything to build this from our shop. Here's some of that's what the assembled board looks like. Here's some example displays. If we move on to the whole house sound system, you can see here how he's mounted some speakers as well as ducts in his ceiling. And in this larger room, he talks about selecting the speakers, selecting the amplifiers. Here's a subwoofer that he's used. Our remote speaker switch that we published some time ago is used for switching his speakers between different zones. And he's also used an equalizer. And this is the system that he's built: indoor and outdoor speakers, indoor and outdoor subwoofers with switching, and 3 different amplifiers. So it's an interesting project if you were thinking of putting a sound system in your home. There's a lot of good information there to help you do that. And here's the simple USB power monitor project. Let's have a look at the circuit here. You can see there isn't much to it. So there's a regulator, this very interesting chip here that does voltage and current sensing, all integrated, and analog to digital conversion as well. So it just connects to the microcontroller, and that lets the microcontroller monitor everything that's going on in terms of power between the USB plug and socket, and then it shows the results on this screen. There's the board, pretty straightforward. Parts list, we also have a kit for this, which is basically complete. There's no case, but it comes with some clear heat shrink tubing if you wanted to put that around the unit to protect it. Some details about programming the chip. It's not necessary if you buy our kit because it comes programmed. So anyway, it does what it says. It's a simple USB power monitor, and as you can see, it handles voltages above 5 volts. I believe it goes up to 36 volts, I believe. So most USB power delivery systems will work with this, but apparently there is a 180 watt scheme which won't. So you do have to watch out for that. Moving on to this e-paper display article. So this ties into the comfort indicator, but it talks in more detail about how the e-paper actually works and how you interface with it and the control signals. And we also talk a bit about color e-paper. We did consider that for the comfort indicator, but basically the bottom line is that the screen refresh takes a long time for color e-paper. So we didn't think it was really suitable for something like this that might update the screen every minute. And here's our radio transmitter project. This is a very minimalist design with relatively few components. Sort of, in a sense, it's quite a good way to learn about how analog radio transmitters work. So there's the first version, and you can see he's used a crystal filter, number of crystals in there, and I think it's 4 transistors in this design, and when it fits inside this case, which was recycled. But if you don't have one, you can 3D print one. And then there's a second version, which is basically the same, but uses slightly different approach to the single sideband generation using different crystals. And here's a simpler version with 3 transistors that basically doesn't need some of these components and uses, again, a different approach on a different frequency. There's 3 different variations of the board. So the same board, it can be used to build all 3 versions, just with different components in different places. And there's some wire links to allow that as well. There's the parts list. So a relatively straightforward project again, a bit of a different subject. And now moving on, this is Serviceman's log, and he talks about restoring this audio interface that started having some problems with the connectors not working properly and the potentiometers scratching and so on. And we also have some information about fixing a washing machine, lithium-ion battery charger, attempting to fix some Dyson bladeless fans, but apparently the driver board is not really available or not at a reasonable price. So he's looking into some alternatives and a Samsung TV. And finally, as I said, we're not looking at every article in the magazine. There are others, but yeah, here's the vintage radio on this Sailor 6060 navigation radio. Not something that you probably wouldn't come across. It mostly was used on ships, but they are available, and he's bought one, and he talks about some of the options, how they were used, how they work, things that he needed to fix to get his working. And apparently, it's quite a good radio, even outside of a ship, a high quality device. When you're out at sea, you need good reception, so it's well designed. And he even talks about how you can adjust the tuning capacitor to make sure that the dial markings match the frequencies you're actually tuning to, so you're tuning consistently across the band. So that's the June 2026 issue of Silicon Chip. I think there are a lot of very interesting articles in there, and hopefully things that inspire people to build stuff. Thanks for listening. My name is Nicholas, and this is Silicon Chip Magazine.